Okay, guys, so welcome back to the part 2 of density and upthrust. From our previous video, we've explained all about density, where we explained that it is the ratio of the mass of the object to the volume of the object. And then we saw formulas where we could relate different circumstances having density 1, volume 1, and density 2, volume 2. Now, in today's class, we're going to be looking at the next topic, which is relative density. Okay, just quickly before we go to what I have on the board, relative density basically is defined as the ratio of the density of an object to the density of water. So when we're dividing an object's density by the density of water, we call that relative density. Okay, now just for knowledge sake, the density of water has a constant value. The density of water is actually 1 grams per centimeter cube or 1000 kilograms per meters cube. So it depends on the unit you are using to solve. If it's in grams per cm cube, it becomes 1 grams per cm cube. If it's in kilograms, it becomes 1000 kilograms per meters cube. Now back to the board. So on the board, we have the formula density of objects divided by density of water. Now I said recall, the density is equal to mass divided by volume. Okay, so we're going to replicate this formula into our main formula for today. So now we can say, therefore, the relative density becomes, for the density of the object, we're going to be having the mass of the object divided by the volume of the object. And then for the one for water, we're going to be having mass of water divided by the volume of water. Now, to make our relative density perfect, we're going to make sure that the volume of water we are using is equal to the volume of the object in question. Okay, so the volume of water must be equal to the volume of the object. Thereby, if you do that mathematically, we'll agree that this volume here can take out this volume here. So we'll be left with just mass of object divided by mass of water. But just to remember, I wrote here mass of object divided by mass of EVW. Now, what does EVW stand for? It means equal volume of water. Okay, so the water must have equal volume as the object. So equal volume of water, the object and the water should have the same volume before this formula can work. Okay, moving on. Now, there are various instruments we use to measure the relative density of an object. Okay, but for our class today, we're going to be looking at the density bottle. Okay, now this density bottle is also called specific gravity bottle. Okay, so in case you don't see this name, you'll see the same thing. Now, it is used to measure the relative density for objects like either solids or liquids. So we're going to group it into two. How do we use to measure the one for solid and also the one for liquids? Okay, to find the relative density of liquid using the density bottle, we're going to go through some experiments. And what are the experiments? We're going to first of all take the empty density bottle itself, very empty, and measure its mass either by a beam balance or a chemical balance. We get the mass, we call that M1. M1 is the mass of the bottle, that's the empty bottle. And then we're going to bring the liquid in question and pour the liquid into the density bottle. But we're going to make sure it fills the bottle, okay? So I'll call that M2. M2 becomes mass of the bottle plus mass of the liquid, okay? And then we're going to take out the liquid and then we'll bring in our reference object, which is water. We're going to pour water into the bottle and make sure the water also fills the bottle. We'll call that M3, that being mass of the bottle plus mass of the water. And then that is the end of our experiment. So we're going to apply the main formula to find the relative density. From our experiments, we have M1, M2, and M3. You can see that to get the mass of the liquid itself, we're going to have to do M2 minus M1, okay? Because M2 has bottle and liquid, and M1 has just bottle. So if I remove M1 from M2, I'm going to be left with what now? The liquid. So the object becomes M2 minus M1. Now remember, we made sure that the liquid and the water filled the bottle at the same time, like separately. So it means they have equal volumes. So basically, the mass of the water we'll have here is going to be having equal volume as the mass of the liquid as well. So to get a mass of equal volume of water, we're going to be doing M3 minus M1. So this gives us the formula to find the relative density of liquid using the density bottle. Moving on, we're going to look at this next part for solid. Okay, now for the solid, we're going to also be applying or doing some experiments, although they're going to be a bit different from that of the liquid. Now let's observe. For the solid, I'm going to also do M1 as mass of the bottle, and M2 is mass of the bottle plus the solid, meaning I put the solid inside the bottle. Okay, now I'm going to leave the solid in the bottle, and I'm going to pour water into the bottle to get M3. So M3 is going to be mass of the bottle plus mass of solid plus mass of the water, okay, that I poured into the bottle, having a solid in it. So that's for M3. And now M4 becomes mass of the bottle plus mass of water. That is, I'm going to pour just water into the bottle alone. Now the water is going to fill the bottle. Okay, so we have like two different parts that has water. We have them in M3 mass of water, but there was solid in it as well. In M4, just the water in the bottle. So now how do we now get the RD for this solid? Very simple. Again, to get the mass of the solid alone, we're going to be doing M2 minus M1. So we're left with MS. Okay, but now to get the mass of equal volume of water, we're going to be very, very careful in this aspect, because we have two waters, pardon my English, in this structure. We have water in M3 and water in M4. We're going to check between the water in M3 and the water in M4, which do we think is going to have the higher volume? Obviously, it's going to be M4, because M4 just has only the bottle empty and then water is filling it completely. But in M3, the bottle had solid inside before we added water. So the water in M4 will be higher than the water in M3. So therefore, to get the mass of equal volume of water, we're going to try and subtract the water in M3 from the water in M4. So before we do that, we need to get the waters alone. So how do we get the water in M4? It's going to be M4 minus M1. So I'm left with water. M4 minus M1. And then the one in M3 is going to be M3 minus M2, because M3 has both bottle and solid, and that's also in M2. So if I'm going to do M3 minus M2, I'll be left with water. So therefore, M4 minus M1 is the water that fills the bottle completely, minus M3 minus M2 is the water that had a solid in it. So this will give you the equal volume of water. Thank you.